Discover how our advanced features and insights empower you to monitor, analyze, and optimize your applications for unparalleled performance and reliability. On the application dashboard, the AppDex score is a quick health check of your applications. Ranging between 0 and 1, it is a standard for measuring application performance with response times, providing a quick health check of your applications. The 3 golden metrics of application monitoring, including load, representing the number of transactions your application handles over time; response time metrics, monitoring how quickly your system responds to requests; and error rates, reflecting the overall health of your application by showing the percentage of transactions that result in errors are part of the dashboard. Additionally, the percentile response time graph provides a deeper understanding of how your application performs under various conditions, showing the response time distribution across different percentiles. As we delve deeper into the specifics of application performance, the endpoint section provides detailed insights into how individual endpoints are performing within your application. The error column here shows the total number of errors that have occurred. This identifies endpoints that frequently encounter issues, potentially disrupting user interactions. The errors per min metric gives insight into the frequency of errors over time, allowing teams to gauge the stability of endpoints under varying loads. Next, response time measures how swiftly each endpoint fulfills a request, a key indicator of performance that directly impacts user satisfaction. A shorter response time usually suggests a more efficient endpoint. Calls represents the total number of requests handled by each endpoint, providing a clear view of the operational workload and popularity of specific endpoints. Higher call volumes might indicate endpoints that are critical to user workflows. Finally, calls per minute quantifies the throughput rate, offering a perspective on how much traffic each endpoint manages per minute. This helps in assessing whether the endpoints are scaled properly to handle peak loads and can guide capacity planning efforts to ensure high availability and responsiveness during high traffic periods. By clicking on any endpoint, teams can access a more detailed view that includes load, error, response time, and percentile response time. This detailed view facilitates a comprehensive analysis of endpoint performance, highlighting potential areas for improvement. The load metric illustrates the total number of requests handled by the endpoint, providing insights into the operational demand and efficiency. High load values may indicate endpoints that are critical to user operations or require scalability enhancements. The error metric quantifies the total errors recorded, offering a direct measure of reliability. Persistent errors in critical endpoints could signal underlying code issues or external dependencies that need resolution. The response time metric measures the time taken for the endpoint to complete a request. It is crucial for assessing the speed of endpoint interactions and identifying delays that could affect user experience, while higher values may pinpoint performance issues or the need for optimization. The percentile response time offers a deeper insight into the distribution of response times across transactions, helping identify variability and extremes in endpoint performance. Additionally, from this detailed view, you can navigate to slow traces. Here you can explore each trace, examining individual spans within those traces to uncover specific reasons for delays or failures. This detailed trace analysis enables precise diagnostic interventions, ensuring effective issue resolution and optimization strategies are applied where they are most needed. Getting deeper into the specifics of application performance, the Instance section provides detailed insights into the performance of individual application instances. Error percentage indicates the reliability of each instance, highlighting the fraction of interactions that result in errors. Monitoring this helps identify instances that may be unstable or require attention. The number of errors and errors per minute offer insights into the frequency and rate of errors, respectively. These metrics are crucial for identifying instances with frequent issues, allowing teams to rapidly address persistent problems. Response time measured in milliseconds reflects how swiftly each instance handles requests. Assessing this metric is vital for gauging the responsiveness of each instance and identifying potential delays. The call and calls per minute metrics illustrate the workload each instance is managing, indicating the operational demand on each instance. By clicking on any instance, teams can access a more detailed view that includes load, error, response time. This detailed view offers a comprehensive analysis of instance performance, highlighting potential areas for improvement. The load metric illustrates the total number of transactions handled by the instance, shedding light on its operational demand and efficiency. High load values may indicate instances that are pivotal to user operations or may require scalability enhancements to uphold performance under peak traffic conditions. The error metric quantifies the total errors encountered, providing a direct measure of the instance's reliability. Persistent errors in critical instances might point to underlying issues with code, configuration, or external dependencies, necessitating targeted troubleshooting and resolution. The response time metric tracks the duration it takes for an instance to process requests, essential for evaluating the operational speed and efficiency. Optimal response times ensure that the application remains responsive to user interactions, whereas longer response times could indicate performance issues that need optimization. In addition to performance metrics, the correlation to infrastructure icon enables teams to view how instance performance relates to the underlying infrastructure metrics. Further, by accessing slow traces from this view, teams can delve into detailed traces of each instance, examining individual spans within those traces to determine the specific causes of delays or failures. This detailed trace analysis enables precise diagnostic interventions. Diving into the database performance analysis, the overall subtab offers a holistic view of the database's efficiency and responsiveness through key metrics such as load, response time, access errors, and percentile response time. The load metric quantifies the total number of calls to the database. Observing peaks in load can help identify high traffic periods, which might require scaling database resources or optimizing query performance. Response time measures how quickly the database processes each call. Higher values may suggest bottlenecks that could impact user experience. Access errors reflect the number of failed interactions with the database. Monitoring this metric helps in identifying issues that may hinder data accessibility, impacting the overall application performance. Lastly, percentile response time offers a deeper analysis by showing the distribution of response times across different percentiles. Switching to the query subtab, individual query statements are analyzed, showcasing their maximum response time, timestamp of execution, and query count. Each query's performance can be scrutinized to determine efficiency and reliability. Queries with high response times or frequent execution may require optimization to enhance database performance and reduce load. Infrastructure monitoring provides a holistic view of the hardware and network resources your application relies on. Here, you can monitor CPU usage, RAM availability, storage available, and network bandwidth. CPU usage percentage reflects the processing power used by each server, indicating the current operational demand. RAM availability shows how much memory is being utilized, helping to identify the active use of memory resources. Storage availability measures the percentage of disk space available, essential for ensuring sufficient data storage capacity without risking system efficiency. Lastly, network bandwidth usage tracks the amount of data being transferred, which is crucial for maintaining network performance under varying loads. By selecting a server entry, detailed graphs provide insights into the performance trends of these metrics, including real-time CPU load, memory usage, disk operations, and network traffic. This granularity helps in pinpointing areas that may need attention or adjustment to optimize overall system performance. For example, a sustained increase in disk read-write operations could signal the need for faster storage solutions or reconfiguration of database access patterns to improve response times and application throughput. In the infrastructure analysis, detailed graphs for each server provide a comprehensive view of real-time system performance. These include CPU load averages, memory utilization, disk read-write activities, and network bandwidth usage. Each graph reveals trends and spikes in resource usage, enabling teams to monitor system health and promptly address any potential issues. This layered insight helps ensure that all components are functioning within their optimal parameters, thus maintaining system stability and performance efficiency. Moving on to the topology view, this provides a comprehensive map of your application's architecture, showing how each component interacts within the system. It highlights dependencies and communication paths between services, databases, and external systems. Each node represents a distinct component, such as a microservice or a database. The connecting lines indicate the interactions and data flow between these components. By selecting any node, you can drill down into more detailed metrics and logs specific to that component, allowing for targeted diagnostics and optimization. In the topology view, you can also switch between map view and table view for different perspectives on your application's architecture. Finally, the trace view provides an in-depth look at the execution path of specific transactions across your application's components. Tracing is essential for identifying performance issues and understanding the flow of requests through your system. Each trace captures the complete journey of a transaction, from the initial request to its final response. This includes all intermediate spans, such as database queries and service calls, with precise timing information. Analyzing traces helps pinpoint slowdowns and optimize overall performance. You can also click on a specific trace to find out the reason for any issues, and even download a report for further analysis. You can view traces and spans in table, list, or tree view as per your convenience, providing flexibility in how you analyze and interpret trace data. An essential part of maintaining a robust application environment is proactive monitoring. With our alerts functionality, you can set up custom alerts to be notified of potential issues before they escalate. Creating alerts is easy. Navigate to the Alerts tab from the main Observability menu, wherein you can manage and set up alerts tailored to specific needs. For instance, you can create an alert to notify you when a particular service exceeds a threshold error rate, which could indicate a potential issue. This is crucial for quickly addressing problems. You can specify the condition, like if the error rate is greater than 0 over a specified time period. You can also set the severity of alert, ensuring you never miss critical issues. Once configured, any alerts triggered will appear in the Open Alerts tab, where they can be reviewed and managed accordingly. This allows your team to respond swiftly to maintain seamless application performance. Notifications can be sent through various channels such as email, Slack, and webhooks. With webhooks, it's possible to integrate alerts directly into ticketing tools like ServiceNow and Jira. Additionally, the Configured Alerts tab lets you review all set alerts, making it easy to adjust parameters or disable alerts as your monitoring needs evolve. Through this comprehensive application, you have the tools at your fingertips to monitor, analyze, and optimize every layer of your application stack. With Rakuten SixthSense, you're not just monitoring, you're ensuring operational excellence at every level of your application infrastructure.